Okay, Assalamualaikum and very good evening to everyone. Okay, this is presentation for Group 3 and our title is Exponential Smoothing. And our team member start with Rutira, Vino, Sarmila, Azi, Rishalini and me Faris as a presenter. Next. Next. Okay, this is the presentation outline for this slide presentation, and I will start the presentation with introduction and end with the conclusion, and followed by the concept of exponential smoothing by Samila, and then application by Faris, calculation of exponential smoothing by Azi, case study which utilize exponential smoothing concept by Vino. Next one is the advantage by Rutira, and finally disadvantage of exponential smoothing by Rishalini. Next. Okay, this is the introduction to forecasting. The definition of forecasting to predicting the future as accurately as possible, given all the information available, including historical data and knowledge of any future events that may impact the forecast. Forecast is commonly used in statistical tasks in business for decision making. Actually, this can be divided into three, which is the first one is the short-term forecast, the second one is the medium-term forecast, and the last one is long-term forecast. For the short-term forecast used in scheduling for personal production and transportation, and up to 1 year, during less than 3 months. But for medium-term forecast, used to determine the future resource requirement in order to purchase raw material, high personnel, or buy machinery and equipment, with duration around 3 months to 3 years, and long-term forecast for strategic planning, which duration more than 3 years. Next. Okay, this is the 5 basic steps for the forecasting. This basic step can be shown in 5 the item as below, starting with the problem definition. The second one is the gathering information. Next one is preliminary analysis, which is we start the graphing the data to help with this analysis. And the fourth step is actually the important part, which is we choosing the fitting model, and exponential smoothing is part of the model we want to choose. And the best model to use depend on availability of historical data, the strength of relationship between the forecast variable, and final step is using and evaluating a forecast model. Next. Next, I will hand over to Samira to continue for this presentation.
Okay, next is concept of exponential smoothing. Exponential smoothing is actually a way of smoothing out the data by eliminating much of the noise, which is random effects. At each period of time, an exponentially smoothed level, which is LT, is calculated, which updated the previous level, which is LT minus 1, as the best current estimated of the unknown constant level of the time series by the following formula. The formula is LT equals to AYT plus 1 minus delta LT minus 1. In the formula, LT represent revised estimate of the level at time. Then delta represent weight placed on current time series value. YT represent the current time series value. 1 minus delta represent the weight places on the last estimated for the level. LT minus 1 represent the last estimated for the level. Next. Okay, and A in exponential smoothing. The idea behind smoothing the data is to get a more realistic idea about what is really going on. The value of the smoothing constant, which is delta, is selected by the modeler. Higher value of delta allow the time series to be swayed quickly by the most recent observation. Lower values keep the smoothed time series flat, as not that much weight will be given to the most recent observation. Usual value of delta are between about 0.1 and 0.7. Then we have to see the graph for delta, which is 0.1 and delta equals to 0.7 later in this module. The value of 1 minus delta is called the damping factor. Next. The level, which is the level of time calculated at time period. is the best estimated at time for the unknown constant. Since that is the best estimated of the unknown constant, it will be the forecast for the next data value of the time series. The basic concept of the exponential smoothing is ft plus 1 equals to level of time, which is LT. Since the model is stationary, it will be the forecast for all the future time periods until more time series data is observed. Next.
Okay. I will present about the application of exponential smoothing, which is widely preferred forecasting method for smoothing and variate time series data using the exponential window function. For exponential smoothing, it is used the short-term forecast when the time series parameters vary slowly over time. Widely preferred statistical technique to forecast time series based on prior assumption by the user, such as systematic trends or seasonality. So please pay attention to the simulated time series graph. Actually, to depend on the method will be used for exponential smoothing based on the trend and also by the seasonality. Next. Okay, there are three main methods to estimate exponential smoothing, which are the first one is simple or single exponential smoothing, the double exponential smoothing, and last one is triple exponential smoothing. To differentiate between these three methods, actually based on the trend and seasonality. So for the single exponential smoothing, which is used when data has no trend and no seasonal pattern. For double exponential smoothing, used when data has linear trend but with no seasonal pattern. And finally, the triple exponential smoothing will be used when the data has both linear trend and seasonal pattern. Okay, for third one, actually this is use exponential smoothing applied 3 times. Next. Next, I am over to Aziz to continue.
Hi, I will explain a little bit about sample calculation of exponential smoothing. So basically, this is the method where combination of the last actual demand and the last forecast to produce the forecast for the next period. So exponential smoothing requires the use of smoothing coefficient where we call alpha. Alpha, we can determine how quickly the forecast responds to changes in demand referred to as a smoothing factor, basically. So this is the formula for calculating the exponential smoothing, which is the new forecast equal to last period's forecast plus with alpha in bracket period's actual demand minus with last period's forecast. So basically FT is the new forecast that we want to find. FT minus 1 is equal to previous period forecast. Alpha is the smoothing factor or smoothing constant. AT minus 1 is basically the previous actual demands. And next slide, please. So this is first example. Assume that we have given alpha, which is the smoothing constant equal to 0.3 and our FT minus 1 equal to 55. So how we want to find the forecast for period 5? So basically we just using the formula FT equals to FT minus 1 plus alpha in bracket AT minus 1 minus FT minus 1. So we can get like 55.58. Next slide. Example 2, below are monthly sales of light bulbs from the lighting. Find forecast sales for June using the following, which is we have given smoothing constant equal to 0.2 and May forecast is 350. So basically, if we already given the previous forecast, which is May, we can find the June already. So June forecast equal to 352. Example 3, next. So this is the third example. So basically from these examples, focus for weeks 4 through week 7 using exponential smoothing of using exponential smoothing with a week 3 forecast of 130 and smoothing factor 0.3. So basically if we already have the forecast from previous week, we can get the forecast for week 7 already, which is 164.7 using the same formula and same method. So example 4, next. So basically by comparing forecast with different smoothing constant, this is only examples where I got come out with different smoothing constant, which is 0.1, 0.3, 0.5, and 1. And you can see from the graph, the forecast, after we compare with our actual demand, we can see that there is unconstant values after we calculate all the forecast based on the previous demand and previous forecast that we have. So basically choosing high value of smoothing constant, which is alpha, when underlying average is likely to change. And then we need to choose low values of alpha when underlying average is stable. So next, I will pass to Vino to continue the presentation.
Okay, this case study is regarding the forecast on inflation rate in South Sulawesi province, and also forecasting in study using exponential smoothing method. So there are two methods that they use in this case study, which is single exponential and also double exponential smoothing. So the prediction results and also evaluated results are using mean square error and also mean absolute percentage error. Okay, so this case study actually applied using quantitative approach, whereby they have collected data for 66 months from January 2013 to June 2018. So basically, this inflation is also an indicator for the economic movement in the city to provide information about the increase in prices for goods and also services in general, which are considered to be basic needs of society. So if we can see in this table, average inflation rate from January 2013 to June 2018 is about 0.442%, whereby the minimum value we can see in July 2013, and also maximum value in the minimum value is in October 2013, negative 0.72, and also maximum value of 3.05% in July 2013. So we need to calculate the standard deviation of the inflation rate is about 0.6925, which indicates the low level of difference between the data and also the mean value. Next slide, please. Next. Hello. Next slide, please. Okay. So this one is on the single exponential smoothing model using 16 time series of data on the inflation rate, which only using one parameter, which is alpha. So the alpha can range between 0 to 1. So this is the formula that we use: ft plus 1 equals to alpha times with xt plus 1 minus alpha times ft. So we need to tabulate to get the using the MSC and also MAPE to get the data, and then from there we need to evaluate the YT and also the FT. So from the 66 data, we need to use this formula to calculate the all the MSC and also MAP for June from the 2013 to 2018. So then they need to calculate the errors to determine the forecasting result, which is the lowest error value taken, and also an accurate forecasting result. So we can see in March 2018, the period has the smallest error, which is negative 0.5349, which means the forecasting result in that period is actually close to the actual data. Next, please. So if we can see from the graph, the actual data plotted and the result of the forecasting using alpha 0.3 and also beta 0.3 shows the forecasting result quite able to follow up, and also the down pattern of the actual data. Next slide, please. So on this slide, we need to actually use on the ft plus m equals to lt plus b tm. So we need to come up with a table which comes up with the standard deviation, bt value, ft value, YT minus FT value, and then we need to calculate the percentage error, and we need to divide YT minus FT divided by YT. Okay, so from there we can get the YT and also FT value with the error percentage. So from here we can see in March, this is only on March data. So in March 2018 period, we have the smallest value of negative 0.4182, which means the period were very close to the actual data. Next slide, please. So this is a comparison between the single model and also the double model. So whereby the estimation result of the forecasting, the value of the forecast error size could be compared by calculating the MSC and also MAPE values. So if we can see the single exponential smoothing is showing the smallest value, whereby the MSC is 0.5560 and also MAPE is 265.7126. So the single model exponential is the most suitable method for predicting the inflation rate of South Sulawesi from January 2013 to June 2018. So next I will pass to Rutira.
Okay, hi everyone. I'll be explaining about the advantages of exponential smoothing method. Okay, according to one of the research by Sri Hari, the data used for time series forecasting technique in real time, which enables it to be used in various industries. For an instance, exponential forecasting can be used in power management, stock market, healthcare, business, marketing, weather forecasting, and inventory control. According to a research paper by ESMA, which employed exponential smoothing technique in agriculture sector, it says exponential smoothing technique is relatively simple yet effective method for capturing and extrapolating trends and patterns in time series data. Moreover, the accuracy and robustness of exponential smoothing estimations are the reason why it is commonly used in applications where multiple series are present, since it requires an automated procedure. Exponential smoothing technique is easy to understand and implement. Most of commercial forecasting software offers exponential smoothing technique in their products. So that's all for advantages. I'll be passing on to Risha to continue on the drawbacks of exponential smoothing method.
Okay, there are some disadvantages on exponential smoothing. One of the main drawbacks is that it is limited by its simple structure and assumption. So exponential smoothing produces inaccurate forecasts when underlying time series has a complex or non-linear pattern. And also it assumes that So it assumes that data is stationary, meaning that it has a constant mean and variance over time. It also assumes that the future is a linear function of the past, meaning that it does not capture non-linear relationship or complex dynamics. Therefore, it may not work well for the data that it has a structural break, cycles, or non-linear trend. Next is exponential smoothing overfit the data if the smoothing parameters are not selected correctly. The technique can be prone to produce spurious pattern and noise in the forecast if the parameter is not well tuned. Third is the exponential smoothing model makes some implicit assumption about the data and underlying process that it generates. For example, the assume the data is stationary, meaning it means variance and autocorrelation do not change over the time. They also assume that the data has no outlier, missing value, or structural breaks. However, the assumption may not hold in many real-world scenarios. The fourth drawback of the exponential smoothing is its bias toward the past data fails to capture the dynamic of the data, which is especially when the smoothing factor is low, This means it may not react quickly enough for the new information or changes in the data. It also underestimates forecasting information that changes in the data. It may also underestimate or overestimate the forecast depending on whether the data is trending up or down. For example, if the data is increasing over time, exponential smoothing may lag behind and underestimate the forecast. Or if the data is decreasing over time, exponential smoothing may overshoot or overestimate the forecast. Lastly, exponential smoothing is uncertainty of inconsistent of the forecast. So the models rely on the quality and availability of the data to produce accurate and meaningful forecasts. However, in the real world, data may suffer from various issues that can affect the performance and validity of the model. For example, the data may have outlier, which has extreme or unusual value that do not have or do not reflect or on the normal behavior of the data. Outlier can distort the forecast and introduce bias in the model. Similarly, the data may have missing value, which are gaps or holes in the data due to the various reasons, such as errors, failures, or delays. Missing value can reduce the amount and quality of the information available in the models and introduce uncertainty or inconsistent in the forecast. So that's all for the disadvantage. Next slide will be presented by Faris.
Okay, thank you to all presenters. Okay, from the advantage and disadvantages that we heard previously, we can conclude that the exponential smoothing gives accurate and reliable forecast to predict the next period. Analysts can analyze the projected and actual demand shown in the estimates for effective demand planning. This helps maintain accurate inventory levels. So basically, we can say that exponential smoothing is important part for decision making. Additionally, methods under exponential smoothing provide support against trend and seasonality components of time series. This is because exponential moving average is focused on the current values. Next. Okay, this is a list of reference that our group used for making the slide presentation. Next. Okay, that's all from Group T. Thank you.